Jesse is a friend.
Hello everyone, and welcome back to the IBM Personal Computer, model 5150. Last time we had a look at a compiler for the basic language, and the compiler allowed us to produce an executable file, a standalone file, which we could run from inside the disk operating system. And we could even conceivably give it to somebody else to run without necessarily giving them access to our source code. And that's the idea of a compiler. So this week we're going to have a look at another compiler for a different language, and so it's going to be the Pascal compiler. So let's have a look at that. The Pascal compiler was available from the very beginning of the IBM Personal Computer in August 1981. And so here's the manual that comes with the compiler, and so we'll just have a look at the introduction up in this manual. And so talking about the Pascal computer language, which was invented by someone called Niklaus Wirth. So Pascal is not an IBM invention. It had been around for quite a while when the IBM Personal Computer came out. And so IBM decided that they would produce a compiler for this language. And so the Pascal language, developed by Niklaus Wirth, has some influences from earlier languages in it. It is a highly structured language, in contrast to BASIC. And so it's in a way it's a cleaner language, or it allows for more complex algorithms to be expressed in a safer way, let's say. And so probably one of the reasons why IBM chose it. There's also very strong typing in the language, so it kind of enforces developer discipline, and that's a good thing in many ways. Now IBM has added some extra goals. So these are the basic features of the Pascal language, and so IBM in their compiler, which they're offering for the IBM Personal Computer, has added some goals in the form specifically of this idea here that operations which are usually done in assembly should be easy to do in the IBM Pascal environment. Essentially what they want to do is to make Pascal a systems language, for it to play the role that actually C came to play, and that at that time the C language already played in Unix environments. And so IBM was clearly attempting to get Pascal into that sort of position for their personal computer. Of course, as it turns out, that didn't really work, and today the C language is a lot more prevalent than the Pascal language, even on PC environments, which is the majority of computers out there today. And so things like Windows NT and all of the later versions of Windows, they're largely written in C, and a lot of the software which is run on those environments is written on C or in languages derived from C, like C++ or C#. But anyway, back in 1981, IBM seems to have gone to great lengths to get Pascal into that position. And so we're going to have a look at that compiler today. So some of the additions that IBM has added to the Pascal language, and those are useful when you want to get into this more systems type of programming. I don't know if we will get to that today. So I think we'll just start with the beginning. So here's a summary of the goals. We'll just try and get a hello world program running to start with. So here's the information about what we'll need to compile programs which we write in Pascal. So the Pascal package, which you could buy, which consisted of 3 5.25-inch diskettes. And they're called Pas1, Pas2, and Pascal.lib. And here are the files contained on this diskette. The manual, which we're reading right now, and this is an interesting paragraph. You need a minimum of 128 kilobytes of RAM to run the Pascal compiler. And the machine which we're emulating in our emulator here is intended to be one of the very first IBM personal computers, model 5150, which had a maximum of 64 kilobytes on the motherboard. That means we can't achieve these 128 kilobytes simply by using the RAM on the motherboard. And so if we were in August 1981 and we wanted to run the Pascal compiler, we would have needed an expansion board, at least one expansion board with an extra 64 kilobytes of RAM, just to be able to run the compiler. So it's a pretty big program, and indeed it's spread over 3 different diskettes. So first thing we'll do is we'll adjust our emulator, as I've done here, to start using 128 kilobytes. And so in 1981, the only way to do that would have been to max out all the RAM on the motherboard, 64 kilobytes, and to add an expansion board in one of the 5 expansion slots with an additional 64 kilobytes. Okay, so now with this extra RAM, we should be able to start our machine. Now let me just eject all of the diskettes and make sure we have DOS in drive A. So we made a backup of DOS somewhere. Here it is. And here's our computer booting into the disk operating system. Once again, probably doesn't support 21st century dates, so we'll just invent some date. Let's say it's 22nd of August 1981. He doesn't like that because we need to write it in American format. And there we go. Okay, now let's have a look at these 3 diskettes. So you can download these images of these 3 Pascal diskettes, and I'll put a link in the description. And so here they are. So let's have a look in drive A at the master diskettes from the Pascal compiler, which I have right here. And so this disk 1 is what the manual calls Pas1. This Pascal 2 is what the manual calls Pas2, and this Pascal disk 3 is what the manual calls Pascal lib. So let's have a look at those. And now we have it, pas1.exe, which is here. We have passkey, some include files, and an assembly file. And so, yep, they're all there. Let's have a look at the second diskette. So that's this one. And that should simply contain a pas2.exe. Let's have a look at that. And yep, there it is. And then the last diskette is the Pascal lib diskette. And so that contains Pascal lib and another file called Pascal. All right. We need 2 diskette drives, which we are emulating. We have a system with 2 diskette drives. It says we need a printer, but we'll actually get by without a printer. We need a display, which we are emulating here. We're emulating the monochrome display. And of course we need the disk operating system, which we're running right now. And then we'll need an additional 5 1/4 inch disk on which we'll be writing our programs. And this manual calls it the scratch diskette. So we saw how to do that in the DOS manual. The way in the chapter on DOS, the way we'll do that is we'll create a new blank image here, and I will call it Pascal programs .image. And so we're creating a 160 kilobyte diskette because this early version of DOS can only handle 160 kilobyte diskettes. And then we need to insert that newly created disk image, which is here, into our B drive. There it is. And then we need to format it. And so there we go. We need the DOS in drive A, obviously, because we have the Pascal diskettes in there right now. So let's put DOS back in there and then try again. Format B. So B contains our new blank image, what this manual calls the scratch diskette. And yep, we're ready. And there we are. No. Okay, so we have our scratch diskette. Now, just as with the basic compiler, it's suggesting that we make backups of our 3 Pascal master diskettes. And in particular, it's suggesting that we make backups using not the disk copy command, but by copying files and additionally copying the DOS system onto the Pas1 and the Pas2 diskettes, so that we don't need to have to keep switching between them and the actual DOS diskette. And so again, that's a pretty involved process. It involves formatting 3 diskettes and copying files over, and then putting the DOS diskette in and copying that over. Additionally, for the linker diskette, it suggests that we copy the link.exe file from the DOS diskette. And that is something different. If you look back at the episode on the basic compiler, the linker was actually supplied with the compiler. In the case of this Pascal compiler, we're expected to use the link.exe from the DOS diskette. So let's quickly have a look. The DOS diskette is already in there. So if we look here, there is actually a linker program on the DOS diskette. And it's the original one from which was built in April of 1981. And so this Pascal compiler doesn't come with its own linker. It asks us to use the one from DOS. And so it suggests that we copy that over onto our backup of the Pascal lib floppy. And so I've gone ahead and done that, and I'll show you all of those disks now. So I have created here a Pascal compiler 1, compiler 2, and a library diskette. And so the Pascal compiler 1 diskette is the same as the master diskette, with additionally the command com from DOS on here. And so the same goes for the compiler 2 diskette that only contained pas2.exe, and so this backup also contains command.com. And then finally we have the linker diskette, which I also backed up, and so that had a Pascal lib and a Pascal file, and I've additionally copied this link.exe also from the DOS diskette. So that's taken care of this here. And so now we can start compiling. Now, before we can compile anything, we need to write a program in Pascal, obviously. And unlike the basic environment, this Pascal compiler there's no Pascal interpreter which we can start to write and try out and debug our program. The nice thing about BASIC is we had that environment there which we could just start and we could write our program and test it in there before we compile it. There is no such thing in Pascal. And so when we want to write a Pascal program, we need some way to actually enter the source code. And so what they suggest we use here is this weird and a little bit idiosyncratic program called edlin, which is part of DOS. Because Pascal itself is just a compiler, there is no editor in there. So I think we're going to have to bite the bullet and start using edlin in this episode to write our programs. So in order to use edlin, edlin is actually also on the DOS diskette, so let's put that back in drive A. Let's get our DOS back up, here it is. And so you'll notice there's the program here, went past very quickly. We can do edlin, and you'll see it here, is an executable on the DOS diskette. And that contains the line editor. And so in order to discover how we should use that, we're going to have to refer back to the DOS manual, which is here. And if we go to the table of contents here at the top, you'll notice there is an entire chapter devoted solely to this line editor, which is chapter 4. Here's the line editor. Okay, so the way we start it up is we enter the word edlin, which is the executable, and then we give it a file name of a file we want to edit or maybe create from scratch. So even if we're creating a file, we still need to give it that file name. And then let's just start it up so you can see what's going on here. So what I'm going to do is, first of all, I'm going to copy this edlin executable onto my Scratch diskette, onto my Pascal programs. Because when we're using the compiler in our A drive, we won't be able to run edlin because it's on the DOS diskette. So if it's on our Scratch diskette, then we'll be able to start it from there, and we won't have to switch diskettes so often. So let me do that quickly. So we copy edlin.com to B, because B contains our Scratch diskette. And so from B, I can now say edlin, and let's start a simple hello.pascal program, like that. And so edlin tells us we're starting with a new file. And we can now create the file with the desired lines of text. And to begin entering text, you must use the I command to insert lines. And so the I command is one of the commands, it's the insert command, which you can use in edlin. And edlin has all kinds of commands. The big thing to remember is you're always editing one line at a time. And so you can edit a single line, or you can insert a number of lines, and you can list a number of lines, and there are all these commands which you can read about here. But the big thing to remember is you're always working with one line at a time. So this star here, this is where I enter edlin commands. And so one command is the insert command, and that now allows me to insert new lines into the file. And since it's a blank file, it's empty right now, and I'm starting at line number 1. Okay, so how do I write my Pascal program? Well, I could go back to the Pascal manual, or maybe I already know some Pascal because it is after all a reasonably well-known language, even in 1981, and so perhaps I have some previous experience with it. And so a Pascal program always starts with the word program, and then we give it a name. So ours will be hello, semicolon, and then we'll just write what we want it to do. So then we use the word begin, which will enclose a block of code, in this case the main program, and then we'll simply use the Pascal statement write line, and we'll give it the string hello world. There we go, and then we end our program with a period. That is Pascal syntax. So if my memory serves me correctly, this ought to be a reasonably good Pascal program. So now when I'm using this insert command, I actually don't want to write a 6th line anymore. So I need to get out of this insert mode somehow. And when you read the manual, you'll discover that the way to do that when you've finished is to press Control Break. It must be in here. There it is. So when you've finished, you press Control Break, and so that's how you get out of this editing mode. And now, just to check things, I can list my file, the contents of all the lines in my file, starting with line number 1. And the command for that is 1L. And that too is explained somewhere. Here it is. So you can start with a line. You can also simply list a range of lines from some line to some line. For example, supposing I only wanted the first line, well, I could go 1,1 list, and that'll just show me the first line. I can also edit lines. I don't know, maybe I didn't want, or I can delete a line. For example, this blank line, maybe I don't want it. So then I can write 2 followed by a D, and that will delete the line. Now, you can't really see what's happening. You're kind of editing, adding and removing lines here. It's not at all WYSIWYG. It's be some years before we get WYSIWYG editors and DOS. And so to see what's happening, it's usually quite useful to list your file after one of these operations, just to make sure you didn't delete the wrong line. Now in our case we did it correctly. Now maybe we want to insert a comment here instead, in between lines 1 and 2, and so I can insert at line 2, so I can specify the line number and then the insert command again. So now I'm adding a new line 2, and what is now line 2 will become line 3. And so comments in Pascal use curly braces. And this program, just to write what it does, prints a greeting to the user. Something like that. There we go. That's all we wanted to insert. So again, we press Control Break. Now let's have a look at what we're doing, and we can see our line is in here. Okay, now I won't go into much more detail into Edlin. You can discover everything you need to know about the program by reading this chapter here in DOS. It's very thorough, and it's just a tool which you need to learn to use to program on this IBM Personal Computer, because it's essentially the only editor which you have which comes packaged with the computer and with its software. And so the final command that we need is the end, which is E, and that will save these lines to our new file. And so if I now have a look at what's on my Scratch diskette, there's a hello pass file there, and I can type out what's in it using the DOS type command, and we can see these are the lines which I entered in Edlin. Alright, so we have a way to create source programs. So we can now go back to the Pascal compiler and see, we've managed to get a hold on this thing, and we created a file with an extension of pass, and so now we can start the compiler. And so the first thing we'll want to run is pass1, which is on the first Pascal compiler diskette. So pass1 will read your source file and check its syntactic correctness. It generates some intermediate files, and it stores those on the Scratch diskette. And these are the intermediate files. It can also create a source listing. That's the same as what the basic compiler did, which is just your program with some extra information about what the compiler is doing. And so here's how you would go about doing that. So we want to make sure that B is our current drive. Well, it already is. We have the Scratch diskette in there with our program. And then we just want to start. We want to put the Pascal compiler diskette into drive A. So let's do that, Pascal compiler 1. And then we simply start the compiler, as is suggested here. So our source file name is our hello.pass, and once again we don't need to write the pass extension because all these DOS programs always suppose particular extensions. And so the object file is hello.object, which is fine. Yeah, sure, let's make a listing, why not? And it also can produce an object code listing, and this is something that the basic compiler didn't do. And that's going to actually print the assembly language which the compiler produces from our hello source program. Now, we haven't really got into assembly language for the IBM Personal Computer yet, so I'm not going to do that right now because this file won't mean much to us. It'll become useful later on when we start learning the actual assembly language of the IBM Personal Computer, and then we can come back to the Pascal compiler and have a look what kind of code it generates. But so for now, I'm going to leave that at null. So there we are. It's checking our syntax, and oh, it's discovered a problem. It is a warning. So in theory, it's not fatal. Let's have a look at our diskette. And so here's our source file. Here's the listing which it produced, and it produced these two intermediate files, which the manual said it would produce. Notice that it hasn't produced the object file. And that is because this first step of the compiler, so this is what we've just done, we need to do a second pass of the compiler, which is going to take these two intermediate files and produce an actual object file. So the Pascal compiler is so complicated that it doesn't fit on one diskette. It is actually bigger than 160 kilobytes. In fact, let's have another close look at what's on disk A, and you'll notice that pass1 is 81 kilobytes in size. Furthermore, we only have 128 kilobytes in RAM. So we can't load anything which is larger than 128 kilobytes. And it turns out that to compile Pascal back in 1981 on this personal computer, well, it takes more memory than is available. And so IBM has split the compilation process into two pieces using these intermediary files. So let's start with pass2 here. So we need to change the drive now and put the Pascal second pass compiler in the drive. And so now if we look at what's on that diskette, we see there's a pass2, and we can simply run that. It's probably explained here somewhere. Yep. So let's do that. A pass2. And it won't ask us for anything because it's going to look for those intermediary files on the scratch diskette and use those to produce the object file. It doesn't need any extra information from us. Now, it'll take a little while. Notice that this pass2 is 99 kilobytes in size, but yeah, it's finished. And so now, if we have a look at our scratch diskette, we no longer have the intermediary files, they've gone, but now the second pass compiler has actually produced a hello.object file. And from this point on, it's very similar to what we did in BASIC. So now we have an object file which actually contains machine language for the bits of code which were in our source program. And just as with BASIC, we could have had several object files, several bits of source code, which we all compile, and then at the end we want to link them all together into a single executable. And so we need this final step here, which is the linker. And so we now need to insert our linker diskette into drive A and start the link program, which we copy, which actually originally comes from the DOS diskette. So let's do that. And the object modules are, in our case, simply hello, but once again, I could have had several, and then I'd write all of them here. My run file, I'm going to call it hello.exe. And I don't really want a listing file for the linker. Libraries, if we look at the manual here, just as in the case of BASIC, this object file already references the Pascal runtime library. Just as BASIC had a runtime library to implement all of the routines in the language, Pascal also has a runtime library which implements all of the routines in the Pascal language. Unlike BASIC, the Pascal library is always linked statically. There's no such thing as a passrun.exe like we had in BASIC. And so there's only one version of this library, and it is pascal.lib, and it's on our linker diskette. And it is a static library. And so that will now get linked into the hello.executable. But once again, the object file knows that that's the library we need, so we don't need to write it explicitly on the command line. And now we get a whole lot of other prompts, and these prompts were removed in the later version of the linker, which we used with BASIC, but in this original version of the linker, we have to answer all of them. Now, fortunately, once again, the hello object file, which has been produced by the Pascal compiler, contains sensible defaults for all of these things, and so we don't need to worry about them, we just need to press enter everywhere. That's essentially what this manual tells us to do. Yeah, and there it is. So we can now try and run that, and we expect hello world to appear on the screen if we wrote our Pascal program correctly. Yep, there it is. So that's pretty good. We can actually produce programs now using a completely different language, and also producing standalone executables, in this case, using the Pascal compiler. So that's another way that we can program this IBM Personal Computer. Now, when we run the first pass compiler on our Pascal source code, you may remember we had this warning, which turns out didn't really affect our code. But it's not really great, and maybe it's a good idea to find out a little bit more about what's going on there. And so, fortunately, we produced a listing file, which is this hello LST file, and that was produced by the first pass compiler. So we can have a look at that warning in more detail. And so here it is. It is warning 238 assumed output. So what exactly does that mean? Well, there's a section in this manual which goes through all of the error messages. I believe it is Appendix A. Let's have a look. Yep, Appendix A is all of the messages. So let's have a look and see if we can find this warning number 238. And we're getting close, 238. Output was not given as a program parameter. Okay, doesn't necessarily help an awful lot. Maybe we can find out what a program parameter is exactly. So let's have a look at the index. Is there an index? There is an index. So what is a program parameter? What does the compiler mean by that? Program parameters. That looks promising. So let's have a look at section 13.5 in the manual. So here we are. This is the section on program parameters. In fact, it's part of the program statement, which is the first statement in the Pascal program. As you can see here, we can actually pass parameters to that program. And so this section explains what happens to those parameters. Most of them are assumed to be command line parameters. So when I run my program, hello here, I could write some parameter on here. For example, something like that. Those would be 3 parameters which I pass to my program. And the Pascal environment will organize these 3 parameters into variables which come into my program in this way by declaring them as parameters to my main program routine. However, there are a few very special parameters, and those are these pre-declared files, as Pascal calls them, input and output. And you can simply declare those in your program statement. To indicate to the compiler that you'll be using the standard input and standard output, that is to say the console input and output features, as if they were files. And so I suspect that what that warning is telling us is that we're actually using the console to output some information, but we never told the compiler that we intend to use the standard output. So probably we need to do that. Let's see if that changes anything. So we will start edlin again, and now you'll see the value of having copied that to the B diskette, since our Pascal diskettes are in the A drive and our Scratch diskette is in the B drive. DOS is nowhere in sight, and so it's useful to have that copy lying around. So let's edit our Pascal program again and start up the line editor, and let's list the contents. And so we're interested in this first line. And so we want to add a parameter here. So we don't want to insert or delete lines, we simply want to change this line. And so if we'd read the Edelin chapter to the end, we'd know that we simply type 1. And now I can type F3, which will give me the existing line, and I can now edit that. And so I simply want to add the parameter output, and that's all I need to do. I don't need to declare its type because it's a reserved word, and so we can simply add them here in the parameter list to our program, and then we don't need a specific type declaration as we would for any other parameters which are declaring. So as you can see in this example, a file has a type associated with it, and so there's this parameter. But output doesn't. The compiler knows that automatically. So let's list our program again, and so we've now added this output parameter, and that ought to tell the compiler explicitly that we intend to use this console output, and indeed we do in this line here. So let's see if that made the warning disappear. So to compile, we need to start with pass 1 again, so we'll insert the compiler 1 diskette back into the A drive and start it up. So we're compiling hello again. Yep, that is good. Let's have another listing. We don't want assembly code, and he'll now run the pass 1. And what do you know? The warning has disappeared. So we've apparently suppressed that warning now by explicitly declaring that we're using output, and we found out about it by checking the error messages and suggestions in the manual. And so that's something that a person in 1981 would have been perfectly capable of doing with all of the resources which IBM provided. So I think that's good news, at least. Anyway, let's compile this program all the way to the end. So we need the second pass compiler, and we need to run that. And then we need to link our object file. So we need the linker diskette in drive A, and then we can run the linker. Okay, and so let's see if we can run it now. And yeah, no change. So we successfully got rid of that warning message, and we didn't break the runtime behavior of the program. So that's great. Now we could try a little bit more complicated program, and as I've been doing in the other episodes, I'll probably want to try our prime numbers program again. So I have in advance gone ahead here and produced a working version of it in Pascal, which is this one. And so we'll have to enter that into a file on our floppy diskette with the Edelin editor. And yeah, this is the program, and so it's very similar actually to the C program which we wrote in the previous series on my 8-bit CPU. It has the right primes, and it runs through all of the candidates using only odd numbers, and then it checks if they're prime by doing a modulo, which is fortunately an operator which is available in Pascal, and then maintains an array of the already known prime numbers and goes through them that way. So let's enter this program into a file on my Scratch diskette using the Edelin editor. So now let's see if I was able to enter that without any mistakes. So let's try our first pass compiler on this source code. So primes.pass this time. Let's make a listing file, and no assembly code object, I believe that stands for. Alright, so I copied that faithfully. Let's try the second pass compiler. And pass 2, and so it will use the temporary files which this first pass produced. No need to answer any prompts. That was successful too, and so the final stage is the linker. Alright, so that seems to have run without errors, and it's produced a primes executable, which is 24 kilobytes, and so we could try and just run that. And there are the prime numbers. So that's pretty much the same speed as we had when we compiled our basic program, which makes sense, because they're both compiled versions, pure machine language versions of some high-level language. Alright, so we have successfully used a development environment here, and it was there from the very beginning, from August of 1981, provided by IBM. I'm not sure if this was also actually developed by Microsoft. It is possible, but it was definitely marketed by IBM to go together with the IBM Personal Computer, and was probably used by a lot of the original or the very first programs which came out for the IBM Personal Computer, because as we saw, it's a very complete environment, has almost 500 pages of a manual description. There is a complete description of the Pascal language and of the extensions which IBM provides, and so it's a very complete environment which can be used to produce standalone executables. So I think I'll end this episode here. We've had a good look at Pascal. In the next episode, I want to have a look at two programming languages which were very widespread on mainframes, in particular IBM mainframes. Of course, IBM in 1981 was known mostly as a vendor of mainframe systems, and the personal computer was really kind of a novelty for IBM at the time. And so they would have wanted to provide, let's say, a bridge or a possibility of using the languages known on their mainframes to developers who wanted to write software on the IBM Personal Computer. Maybe even a possibility to port over some of the programs which were in use on mainframes, IBM mainframe systems at the time, and use them, compile them, and use them on the personal computer. So those two languages are COBOL, the common business-oriented language, and Fortran, which is the formula translator. So see you in the next episode.